Hello class, and welcome to lesson 4.2 on multiplying fractions and whole numbers. So here's our warm-up for the day. I want you to identify which of these are the commutative property. The commutative property is an activity that can be performed in any order and still have the same outcome. So it's what can be performed in any outcome and still get the same answer. So I can do it in any order I want, but my end result will always be the same. So using the participant section, I want you to give me a yes or a no if each of these are the commutative property. 12 divided by 6 and 6 divided by 12. Are those two the same? Can I do that in any order and get the same answer? So can I do those in any order and get the same answer using the yes or no button? The majority of you started saying yes, but I think that you saw afterwards that it's no, because now we got 14 of you that said no. Let's look at this. Lucas, what is 12 divided by 6?
12 divided by 6 is 2.
Is 2. Excellent. Camilla, do you know 6 divided by 12? What is that?
I think it's like 0.2.
It's not 0.2, but it is 1/2.
Or, yeah.
Exactly, because 6 is 1/2 of 12. So it's 1/2. Those two are not the same thing. So that is not the commutative property. Let's go to our second one. Tying your left shoe and then tying your right shoe. Basically, do we end up with the same results at the very end? Hit yes or no. Yes, my lovely people who have participated, yeah. It doesn't matter what order we tie our shoes in. We still get our shoes tied on, right? How about the next one? 5 times 7 and 7 times 5. What do we think? Are those the same thing using our participant button, yes or no? Yes, the majority of you said yes. It is the same thing. 5 times 7 is 35. And hey, 7 times 5 is 35. With multiplication, it doesn't matter what order you put them in. With division, it does. What about this next one? So you play a soccer game and then you put on your uniform. Is it the same as if I flipped it, put on my uniform, and then played a soccer game? What do we think? Yes or no? Yeah, you guys are saying no, exactly. It's not the same. If I play a game and then put on my uniform, that is not the same as if I put on my uniform and then played a game. And then lastly, 15 plus 5 and 5 plus 15. So what do we think? Are those the same? Yeah, we know that. Both of them equal 20. So I want you guys to think, and I want someone to raise their hand. So the commutative property does not work with division, but it does work with multiplication. It also works with addition. What do we think about subtraction? What do we think about subtraction? Is the commutative property going to work with subtraction? Ella, what do you think?
No, because if you flip it around, so say if I had...
So she says no, and what is her example?
Because say if we have 15 and 5, you can't do that, because if you flip it to 5 over 15 when you're trying to solve it, it just doesn't work like
Exactly.
that.
It does not work. So the commutative property works with addition and multiplication, but it does not work with division and subtraction. So exactly, you guys are perfect. Now I've got another question for you guys. What is 2 as a fraction? You're like, what? 2 is just a number. But what is 2 as a fraction? Amelia, what is 2 as a fraction?
2 over 2.
2 over 2. What do we think? Is that the answer? What do we think? Dolan, what do you think?
I think that 2 could also be 1/2 because it's 1/2 1.
Do we think 2 is also the same as 1/2? What do we think? Lila, what do you think?
I think it's 1/5.
1/5? No. It's not. Cynthia?
I think it's 2 dash 1.
2 over 1?
Yeah.
What do we think, you guys? Nodding or? Yeah. It's 2 over 1. The over part means divide. Remember how we've seen that before? You know, if I had 12 over 6, that equals 2, right? 12 divided by 6 is 2. 2 over 1 is the same as 2. Everything can be a fraction. Does dividing by 1 change anything, you guys? Nodding or shaking our head? Dividing by 1 does not change anything. So look at that. No matter what it is. Heart over 1 is just heart. 7 over 1 is just 7. 200 over 1 is 200. Star over 1 is just star. Tom Nook over 1 is just Tom Nook. It doesn't matter. They're all the same. Dividing by 1 changes nothing. So I want you to copy this down though. When we're multiplying with fractions, we cross cancel and we across multiply. So we cross cancel and we across multiply. Here's my first example. I have this number. Brian, what number is this right here? 5. Julian, what number is that right there? The one that I circled. 3. And then Lucia, what number is this right here? 4. Perfect. So what we have is we have 5 and 3/4. But I have to make them both into fractions. Although making a whole number into a fraction is super easy. All I have to do is add a 1 underneath it. So the first step is we made it into a fraction. Making a whole number into a fraction is just as easy as putting it over 1. Then we across multiply here. We across multiply. And then we have to simplify. So we get what here is an improper fraction. 5 times 3 is 15. 1 times 4 is 4. We get an improper fraction and I simplify it into a mixed number. So here's how you go from a mixed number to an improper fraction first of all. You multiply the integer, which is our big number, by the denominator. You add the product, which is our answer for multiplication, as we know, to the numerator, and then we keep the denominator the same. Here's a little thing that I made which shows you exactly step by step. I used it with letters. The letters are just placeholders. Remember what I told you about X being a placeholder? These are just placeholders where you can put in any number you get. And then I showed you an example on the other side. I also showed it to you with what's called an area model, 1 and 2/3. So I have 1 pie and then I have another 2/3 of a pie. And I split them into pieces. And based on that, I have 5/3 of pieces of pie. I have 5/3 pieces of pie. I'll show more examples after. But as we see, like with our area model, here I split the pie. I had 2 pies. 1 full pie, and then another pie that I only ate 2/3 of. I split each pie into 3 parts, because that's the point. I'm dividing them by 3. 1 whole pie, and then 2/3 of a pie. I have 1, 2, 3, 4, 5 pieces, and they were each split into 3 parts, giving me 5/3. Before we move on, before I give another example, I want to show you how to go from improper to mixed. So the first thing is, we follow Price is Right rules. Price is Right rules is this. You can't go over. You make a bet of how much something costs, but you can't go over. We can't go over. So we have to follow Price is Right rules. First thing is we find out how many times the denominator goes into the numerator without going over. Then we subtract that. We subtract that product. That number is the new number. So for example, we're looking at that and the denominator still stays the same. 5/3. On your fingers, how many times does 3 fit into 5? We can't have it go over, so how many times? Yeah, it fits in 1 time. 3 fits in 1 time. That became our new integer, our new big number. And it fit in 1 time, so I took away just the 3, because that's 3 times 1. And so we do the 5 minus 3 equals 2. That became our new numerator, and we kept our denominator. Do we see how this is the exact same example in reverse as what we just did here? 1 2/3 became 5/3. And then 5/3 became 1 2/3. So we see all of that right there. They just work in reverse. So from improper to mixed is following Price is Right rules. Here's another way that we can see it. I'm going to have 7 halves. One thing I'm going to do is I'm going to draw 1, 2, 3, 4, 5, 6, 7 dots. We already know I'm going to keep my denominator the same. Denominator never changes. But I want to group them into groups of 2. There's a group of 2. There's a group of 2. There's a group of 2. Can I make any more groups of 2? Can I make any more groups of 2? No, I can't fit in any more groups of 2. Brian, how many groups of 2 did I make? How many circles do I have? So I have 3 circles. That becomes 3. And how much is left over? Show me on your fingers. How much got left out? 1. So that's another way that you can look at it. You can use the dot method. You can use the dot method. The dot method gets a little bit annoying when you have stuff like 86 because you don't want to draw out 80 dots and then group them in groups of 6. But what it is that it works very well if you're having trouble in the beginning. So I draw my 7 dots, my 7 parts, and I split them into the 2 groups. So I have my 7 dots. I find out that I can group them evenly 3 times into groups of 2. And then I've got this sad leftover little dot. Poor little leftover dot. But that little leftover dot becomes its own little number. He's still there. He still works. It's awesome. So that's another way that we can see this. I want you guys to practice these first. We're just going to do the multiplication. Now, 2. What is 2 as a fraction, Vahe?
2 as a fraction is 2 over 1.
2 over 1. Camilla, what is 6 as a fraction?
6 as a fraction is 6 over 1.
Yeah, 6 over 1. Dolan, what is 9 as a fraction?
9 as a fraction is 9 over 1.
9 over 1. And then Pearson, what is 4 as a fraction?
4 as a fraction is 1 over 4. 1 over 8.
You're getting... No, 4 is a fraction. 4 over 1. Here, we're going to multiply. So now what I have is 2 over 1 times 2 over 5. I simply across multiply. Ella, what is 2 times 2?
4.
What is 1 times 5?
4.
Perfect. 4 over 5. That's it. Congratulations, Ella. You just solved that problem. Let's look at this next one. I have 6 over 1 times 2 over 3.
Wait, Miss Diaz, that's all you have to do?
Vahe, what do I do here?
You multiply CX times 2.
And what do I get?
You get 12.
And then what's 1 times 3?
1 times 3 is Y. It's 3.
It's 3. So I get 12 thirds. However, I can simplify this. In fact, I can simplify it in the beginning. That makes it actually easier for me. So let's go back first. This is our cross cancel. I want to find out what their greatest common factors are, and I can divide by that. So we cross cancel. That means that we're looking like this. Do 2 and 1 share a factor that I can actually divide by that matters? Nah, they only share 1. And dividing by 1, as we stated earlier, doesn't matter. What about 6 and 3? Do those share a factor that we can divide by? Do those ones share a factor? Lucia, what factor do they share?
3.
3. I'm going to divide them both by 3. I'm going to cross them both by 3. So I divide them both by 3. 6 divided by 3 is 2. 3 divided by 3 is 1. Then I just just multiply across. Sebastian, what is 2 times 2? 4. And what's 1 times 1? 1. 4 over 1. Anything over 1 is just that. So I get 4. That's the exact same, by the way, as 12 over 3. Like I said, that's the exact same as 12 over 3. Because who can tell me, Jessica, what is 12 divided into 3 groups? Perfect. So it's 4. We want to cross cancel in the beginning because when we cross cancel, we know that we've already solved it and that it can't be simplified. 9 over 1 times 1 over 3. Here, I want to see. Cynthia, is there anything I can cross cancel here? I can cross cancel the 9 and the 3. What are they both divisible by?
3.
3. 9 divided by 3 is 3. 3 divided by 3 is 1. 3 times 1 is what, Cynthia?
3.
1 times what is what, Cynthia? Anything over 1 is just itself. Congratulations, we solved that problem. Here, I have 4 over 1 times 1 over 8. Dolan, is there anything that they can both be divided by? What can they both be divided by?
Me?
Yeah.
They both can be divided by 1 and 2.
They can both be divided by 4. So as we see, 4 divided by 4 is 1. Dolan, what's 8 divided by 4?
8. No. 4.
2. Exactly. 1 times 1 is 1. 1 times 2 is 2. So I get 1/2. Well, we already know. I'm just going to put all of these over 1 because we already know that. I get 3/5 times 4 over 1. Lucas, if I'm looking at the crosses, if I make it into a cross, is there anything that I can simplify here? 3 and 1, can I simplify those at all? 4 and 5, can I simplify those at all?
You can simplify 3.
Exactly. Lucas says we can't cross cancel. So we just got to multiply across. 3 times 4 is 12. 5 times 1 is 5. But that's an improper fraction. That's an improper fraction. I want to know, Ella, how many times does 5 fit into 12 without going over? How many times does 5 fit into 12 without going over?
2.
2 times. That's my new big number. And what was 2 times 5? 10. I'm going to take that away from the 12 because I just removed it. What is 12 minus 10?
12
Is 2. And then we keep our denominator the same. These two are the exact same. 12/5 is the same as 2 and 2/5. 12/5 is the same as 2 and 2/5. The next one. 1 over 4 times 5 over 1. Camilla, can I cross cancel anything there?
No.
No. So I just across multiply. We get 5 over 4. How many 4s fit into 5, Camilla?
1.
That's our new big number. Our denominator stays the same. And then we take away how many 4s fit in. That was 4. What is 5 minus 4?
That would be 1.
Perfect. And if we're having trouble understanding that again, let's make my 5 dots. I'm going to sort them into groups of 4. I have one group of 4 with one sad dot left over. One group of 4 with one sad dot left over. Lucia, 1/2 and 3 over 1. Can I simplify it? Can I cross cancel anything?
No.
No. So I'm just going to across multiply. What's 1 times 3?
3.
2 times 1.
2.
How many 2s fit into 3?
1.
New big number. What's 3 minus 2? That was how many it fit in?
1.
Perfect. So I get 1.5. Again, I could do the dot method. 1, 2, 3. I want to group them in 2s. I only have one group of 2s and 1 sad leftover dot. Let's see. Marjorie, 2/5 and 4/1. Can we cross cancel anything there, Marjorie?
No, because they're like that.
Yeah.
Diagonal.
We can't cross cancel because 2 and 1 are already simplified and 4 and 5 don't share a fraction. They don't share a greatest common factor. So now we just cross multiply. Marjorie, what's 2 times 4?
8,
What's 5 times 1?
5,
How many 5s fit into 8?
1,
We already keep our denominator. And what's 8 minus 5?
3,
3. If I made my dot method, 1, 2, 3, 4, 5, 6, 7, 8. I'm going to group them into groups of 5. Merp. I only have 1 group of 5 and then 3 sad leftover dots. Let's look at this one. Here, I've got 3/4 times 5. We make it 5/1. 3/4 times 5/1. Nodding or shaking our heads. Can I simplify these? Do any of them share a greatest common factor? No. So Lila, we're going to multiply across. We across multiply, Lila. What's 3 times 5?
15.
What's 4 times 1?
4.
Perfect. You can use the dot method, or you can tell me, how many 4s fit into 15 without going over? 3. We always keep our denominator the same. What was 3 times 4, Lila?
3 times 4 equals to,
Lila's
okay.
mic isn't working, so what is it, Sophia? Or Ella, I mean, sorry, Ella?
okay, good. 12.
12. So I'm going to take away 12. Ella, what's 15 minus 12?
I think 3.
Yep, that's our answer. A sloth spends 4/5 of its life asleep. If a sloth lives to be 28 years old, how many years does it spend asleep? So we have 4/5. And we're multiplying it by the amount of time it lives. It lives for 28 years. As a fraction, that's 28/1. Camilla, can I cross cancel anything? Do 5 and 28 share a factor?
No.
Nope. So I can't. I gotta multiply. I cross multiply. What is 5 times 1, Camilla?
5.
Do you know 4 times 28?
No, but I'm going to do it right now.
So what is it, Camilla?
I got 112.
Perfect, 112. See, these are the situations where I don't want to make all of these dots. I don't want to make 112 dots and put them into 5 groups and circle them in 5s. We want to think how many 5s fit into 112. Let's split it up. Lucas, how many 5s split into or go into 100?
How many 5s oh my gosh, 20.
20. And how many 5s go into 12?
12, oh my gosh, 2.
2. So I know that my big number is now going to be 22. My small number is 5. I know that I took away 110 because I had 2 left over. So I get 22 and 2/5. Excellent. I got 22 and 2/5. So go to the guided practice on page 268. So go to page 268. Here are our guided practice. So Sophia, what is 10 as a fraction? 10 over 1. And I want to look at this. Can I cross cancel anything? So let's see. I make a cross, right? I make my cross. 1 and 4, can I cross cancel that?
Yeah.
What can I cross? Perfect. We can't change that. But what about 10 and 5? Are they divisible by the same thing?
Yeah.
What are they both divisible by?
By 2.
Yes, they are both divisible by 5. Sophia, what is 10 divided by 5?
I'm sorry, I can't hear you.
What is 10 divided by 5?
Oh, 2.
2. And what's 5 divided by 5?
1.
So I just got rid of them and I changed it. Oops, as I put a 2 there. I just got rid of them and I changed it. I divided by their greatest common factor. And then all I'm going to do now, Sophia, is across multiply. What is 2 times 4?
8.
What is 1 times 1?
1.
So my answer is 8. Excellent. Ella, what is 2 as a fraction?
2 over 1.
2 over 1. Excellent. And then I'm going to look at see if some of these I can cross cancel. I want to see if I can cross cancel some of these. Can I cross cancel 3 and 1? Are they divisible by anything that matters?
No.
No. What about 2 and 4? Can I cross cancel anything there? Are they divisible by something?
Yeah.
What are they divisible by?
2.
2. Perfect. So what is 2 divided by 2, Ella?
1.
What is 4 divided by 2?
4, 2.
Perfect. So my new ones are 1 over 1 times 3 over 2. I just across multiply. What is 1 times 3?
3,
What is 1 times 2?
2.
I get 3 halves. But that's improper. I want to make it into a mixed number. Amelia, how many 2's fit into 3 without going over?
1.
1. We already know I'm going to keep my denominator the same. 1 times 2 was 2. I'm going to take it away from my numerator. What's 3 minus 2?
1.
Perfect. I get 1.5, which is the exact same as 3 halves. Those are the same things. Lucas, let's do this one. We already know that 11 as a fraction is 11 over 1. Can I cross cancel anything here?
No.
No. So I just gotta multiply across. I across multiply. What do you get when you across multiply?
3 times 11 is 33.
Uh-huh.
8 times 1 is 8.
Perfect. So we get 33 eighths. But I want to simplify that. How many eighths fit into 33?
4.
4. So my big number is 4. And what was that? What is 4 times 8?
32.
32. I'm going to take that away from my top number. What is 33 minus 32?
1.
I get 4 and 1/8. Those are the same numbers. 33 eighths is the same as 4 and 1/8. Vahe.
What I do. That's actually what I do. Well, I mean, it's kind of a little bit different, though.
Can I cross cancel anything here?
No.
No, I can't. 9 and 7, 3 and 1, I can't do anything. So I gotta just multiply. Vahe, what's 3 times 9?
3 times 9 is 27.
7 times 1.
7 times 1 is 7.
How many 7s fit into 27?
3.
3. My denominator always stays the same. And what was 3 times 7, Vahe?
3 times 7.
Yep.
27.
3 times 7?
Oh, 3. Yeah.
21. So I'm going to take that away from my top number. What's 27 minus 21?
27 minus 21 is 6.
And that's my answer. 27 sevenths is the same as 3 and 6 sevenths. I've got this one. A cat spends 2/3 of its life asleep. If a cat lives to be 15, how many years did it sleep? So I got 2/3 times 15 over 1 because we have to make it into a fraction. I want to see. Ben, can I cross cancel anything? Three and 15, what are they both divisible by?
5. No. 3.
They're divisible by 3. 3 divided by 3 is 1. What is 15 divided by 3?
5.
Perfect. And then I just across multiply. What is 2 times 5, Ben?
2 times 5 is 10.
What is 1 times 1?
1 times 1 is 1.
10. The cat spends 10 years of its life asleep. Your homework is page 269, numbers 1 through 9.